Hello, my name is Christian Williams. The date is October 12th of 2021. This is for the CIRC04 C Attempt. This program we are learning how to do a basic servo motor setup. In this case, causing it to rotate from 0 to 180 degrees. First, I'll go into the code, although I think the wiring is going to be a little bit more interesting to explain. So up here in the code, by now you've probably gotten used to having just setting up your variables and so on, but we did something a little different with this one. We've learned for a while in this class about the importance of including what's known as a library in order for our code to understand. So in order to communicate to the servo and tell it what to do, we had to tell our program to include a servo library. This allows us to create a servo object in order to control said servo. Then we named our servo. You can see in the orange text, my servo, but that we can name to anything. So we can do up to 8 servos, it looks like, with this library. So we could do servo 1, servo 2, but in this case we're just naming it my servo. And then we are setting up our variable to have position. So position equals 0. We want our initial position to be 0. This stands for integer, not initial. Don't get confused. Then we have our setup. So our my servo is attached to pin 9. Attach is something that is specific to this library as opposed to pin mode. And that just tells our Arduino that pin 9 is connected to a servo. And then we move into our loop. So whatever position first our servo will go to position 0, whatever it's set to. And then it will go from that point up in 1 degree increments up until 180 degrees. So it'll slowly rotate from 0 to 180 degrees. And then once we're at the 180 degree point, we'll then start to move down from 180. So we'll go 179, 178, and so on, all the way down to 0 degrees, each time with a delay of 15 milliseconds. And it'll just continuously loop that. So once it reaches the end of the program, it goes back to the top of the loop. So it's at 0, so it'll go to 180, and then 0, then 180, so on and so forth until the Arduino runs out of power. Kind of wanted to talk a little bit about the wiring here. So I want you to notice this schematic here. It's fairly simple. We don't have to do anything with resistors or transistors or anything like that. There are 3 wires. There's a power, ground, and signal to correspond with the power, ground, and signal for the servo listed here, for the mini servo listed here. And then, of course, in the bottom left, we have where it's actually connected to power. This schematic here is just kind of another way of writing it. The servo picted in here is different than the one in real life that I have. So I had to wire it slightly differently. So if we transition to the actual board here in real life, you can see it's fairly similar. I have our ground, power, and signal. But if you notice here, the white cord listed here is signal. Whatever cord is going to pin 9 has to be in the same row as the signal wire. Whatever cord is going to the power, or positive, has to be lined up with the positive inside the servo, so the red wire to the red wire. And then the ground has to be in the same row as the ground for the servo. The 3 wires here are slightly different on my servo. So, if we go here, you can see we're plugged in, we have ground, signal, power. And so I can't use that schematic here. So what I have instead is I have the top green wire going to ground, because the top cord here is ground. And then I have the middle row connected in my orange wire, which is on this board, it's in row 6, and it's going to pin 9. And then because of this red wire here in row 7, I have it connected to the positive here. And that's because I have the positive and the negative going from the power over here. So in the schematic, it's slightly different because the signal is on the bottom, but in this case, because my 3-pin header has the signal in the middle of the ground and the live, I have to wire it slightly differently. So the important thing is to note that signal has to be in the same row as signal, ground has to be in the same row as ground, and power has to be in the same row as power. So following this schematic exactly as described up here would not work in real life because of the servo that I have. And as proof that I did get it to work, there's our little servo. So you can see it going from 0 to 180, and it'll just continue to do that until we run out of power. So it's clearly powered up correctly and receiving a signal. So I just wanted to kind of highlight that little difference here, because it might make wiring and following schematics and other problems slightly easier to follow. So yeah, so that is CIRC04 C Attempt, and I'll see you in the B attempt.